In these problems, we're dealing with geometric proofs. And this is a subject that sometimes gives students a little bit of trouble. A proof, they can be pretty big and complicated, but really what a proof is, it's just a way to lay out an argument, to kind of prove something in geometry is true by building it up out of the other little bits and pieces of things you already know. It's the main way that knowledge about geometry has been increased over time, so it's kind of an important thing. Let's look at the given information here first, and then we'll look at the structure of a proof. And our job in this one is just to find one little piece of it to fit in there. So I don't think this first one will be too hard. But what we've got up here, it says, what is the missing reason in the proof below? And it says, given the measure of angle L equals 61. I'm going to write that in. I think that's very important. Add to your diagram. The measure of angle M equals 60, and prove that this is 59. Well, that hopefully seems pretty obvious to you. The measures of the angles of a triangle add up to 180, so if you've got one that's 60, one that's 61, the other one's going to be 59. So hopefully that seems pretty straightforward to you. It's the form of a proof that sometimes gives people a little bit of problem. In a proof, we have two columns. We have our statements, and then we have the reasons for those statements. And we always begin with our givens. So there's something, information that you're given, and you always end with the thing you're trying to prove. So 1 and 4 are gimmes on this. You have the givens, you have what you want to prove, and it's just these two steps in the middle that you'd have to fill in. In this case, given the measure of angle L equals 61, the measure of angle M equals 60, then, number 2, measure of angle L plus the measure of angle M plus the measure of angle N equals 180. And that's just what we were saying. The measures of the angles of a triangle add up to 180. And then we just do the little math here. 61 plus 60 plus the measure of angle N equals 180. And therefore, measure of angle N equals 69. You just subtract those two from 180, you get 59. So the reasoning seems straightforward here. The reasons for each of these statements, well, the first one is given. The second one, well, that's what we have to find. So let's look at our choices. And the first one we get is the sum of the angles in a triangle is 180 degrees. And that's just what we were saying, so I think that's the right answer. The next one, the reason is the substitution property. And that makes sense because you're taking these given values and substituting them into your rule about sum of angles in a triangle. And then the last one, the reason is the subtraction property, which makes sense because to get to n equals 59, you subtracted these from 180. So that's really all there is to that one. Let's look at another one. All right, so same situation. We've got a proof here, and it's missing one reason. So let's take a look at the figures here first. We've got n is perpendicular to m. So here's n, and it's perpendicular to m. N is perpendicular to L. Oh, so it's perpendicular to L as well. Okay, so these two lines are going to be parallel then. And then it says segment AB is congruent to segment DE. So here's AB, here's DE. Prove that triangle ABC, so this guy right here, and EDC, this guy right here, are congruent. Well, let's take a look at the proof now. It starts with n is perpendicular to m and n is perpendicular to L. That's given. And segment AB is congruent to segment DE. That's given. And here we go. We've got to find our reason here. The statement is angle ABC, so this angle right there, and angle EDC are right angles. So why are they right angles? How do we know that? Well, we've been told that L and N are perpendicular, and that's what happens. That's the angle you get when two perpendicular lines cross. So this has something to do with the definition of perpendicular line. So let's look at our choices here. Vertical angles are congruent. We're not really dealing with vertical angles there. All right angles are congruent. Well, these are right angles, but that's not really a reason why those are a right angle. And C, perpendicular lines form right angles. Aha, so that seems like it fits. And oops, looks like there's another section we have to get here. I didn't see that at first. All right, so let's move on. Triangle ABC and triangle EDC are right triangles. Well, that makes sense. We've just proven they have right angles in them, so that's from the definition of a right triangle. And then we have some missing statement, but the reason that goes along with it are vertical angles are congruent. And if we look here, ACB, which would be this angle, is congruent with ECD, which would be this angle. That really fits with the vertical angles are congruent because these are vertical angles. And the proof goes on to show that these triangles are really congruent triangles by a special rule. But that's all we needed to do was find those two missing pieces. Let's do one more. And this one is much more involved. What you'll see here is we've got 4 different missing statements and their reasons. So a little bit tougher. But before we look at that part, let's just look at what we've got here and figure out how we might think about this before we get to the proof. First of all, we've got this. Given DC is congruent to DB. So this line and this line. And what you should already be saying to yourself is, aha, this is an isosceles triangle. And that might be important here. Now we've got AB is congruent to AE. So that's this one and this one. And aha, it's another isosceles triangle. So we've got 2 isosceles triangles. And then it says prove that the angle D, so this one right up here, is congruent to angle A. And what you should notice is that both of those are the vertex angles of the isosceles triangles. And there's one other thing going on here. There's a vertical angle here. So this angle and this angle are going to be congruent. And that's one of the base angles. And what that means is that the other base angle is going to be the same. And the other base angle down here is going to be the same. And if these base angles are the same here, well, the vertex angles are going to be the same. So that's a preview of the reasoning. Let's see what they're doing here. We start with our givens. Segment DC is congruent to DB. Segment AB is congruent to AE because it's given. And then we skip a step. And then we get the vertical angle theorem. Well, let's actually take a minute to preview our choices down here. What you'll see, we want to fill in A, B, C, and D in the right places here. And you get a statement and a reason for it. And then if I peek even further down here, we've got, just a few choices of the order. The first one says the measure of angle D plus measure of angle C plus measure of angle DBC equals 180, and same, so that's for this triangle, and same for the other triangle. They both equal 180. That makes sense. And then we've got this almost the same thing, except they're being set equal to each other. So it looks like B would follow A. If you say one triangle angles equal 180, the other equals 180, then you can say that they equal each other. C says angle C is congruent with DBC. And those are the base angles. So that's the idea. You get this from the isosceles triangle theorem. And then they say the same for the other one, that the base angles have the same measure. And then finally, we have the measure of DBC equals the measure of ABE. And that's here on the vertical angle. Those are the vertical angles. And that's the definition of congruent angles. Well, this one is something you should kind of get to know, because when you say that the measure of an angle equals the measure of an angle, usually that follows the idea that the angles are congruent. Angles are congruent, therefore their measures are the same. So if I look up here in the proof, I notice at number 3 we have DBC is congruent to ABE. It would make sense to put the measure being equal right after that. Those are the same angles. So I'm going to put D in right there. So I've got 1. I think that's right. And what that might do is help me narrow things down. So where is D in the second place here? I guess in all of these. So I can just cross out A. So I've made a little bit of progress on the process of elimination here. Now, let's try to find our missing piece for number 2. We start with the fact that we've got 2 congruent sides on each of these triangles. What we should do then is realize that they're isosceles triangles and get some further reasoning from that. So I'm really looking down at C next. It says C equals DBC, so the 2 base angles, and E equals ABE, 2 base angles are congruent. and coming from the isosceles triangle theorem. So I think C is going to be the right next piece of reasoning. So just to review so far, we've said there are two congruent sides in each of these triangles. Therefore, there are two congruent base angles. And then we're saying these two are vertical angles, so they're the same. And then we're saying their measures, the measures of these two are the same. Then the next step says angle C is congruent to angle E. So this one, and that's by the substitution property. And I think that makes sense because they're both base angles in these pair of isosceles triangles. So if one base angle is the same, then the other base angle has to be the same. And their measures have to be the same. And now, well, we only have two left. And what I've said already is that it looks like B should follow A, because all the angles of each triangle add up to 180. If they each add up to 180, you can set them equal to each other. So we would say A and B. And then just to finish off the proof, if they're set equal to each other, then you can kind of cancel out the things that you've said are the same and end up with the fact that D and A have to be the same as well. So we've said that C and E are the same, and this angle and this angle are the same, and the only one that's left would be D and A. Whoops. We've said that C and E are the same, that that these two angles are the same, so the only two left would be D and A. So it looks like our correct answer is going to be C, D, A, B, and that would be answer C. Kind of a lot of work. Usually takes a while to get used to these, but keep plugging away at it. I'm sure it'll make sense eventually.